We're here with Ran, founder of Zama. You've been in the tech encryption space for a long time. How did your career start?
When I started getting to AI, it was my first year in college. And at that point, I discovered that you could actually teach machines to do things. And that was like, clearly, this is where the future is going. But we didn't realize at the time that...
What was your first encounter with crypto?
I got back into crypto in 2013, bought some Bitcoin, bought some ETH, lost everything in 2017. From that day, my strategy has been very simple. I only invest in...
Phenomenal. Excellent. We're here with Ran, founder of Zama. I want to start with a little bit on your background. Obviously, you have a highly technical background, and you've been in the tech encryption space for a long time. How did you start? How did your career start? What's the formational moment there?
So it started when I was a kid, 5, 6 years old. I used to love electronics. My favorite thing to do was dismantle TVs and washing machines at home. And so at some point, my mom was a little bit, tired of having to, fix everything all the time. And so she's like, okay. She put me in front of a computer and she's like, you can do whatever you want with software, no problem. Just stop breaking the hardware, effectively, right? So I started coding when I was 10 years old, built my first company as a teenager in the 90s. It was a social network in Europe, quite popular at the time. And then went on to study computer science, eventually did a PhD in machine learning applied to biology when I was 21. And since that day, I've always been passionate about artificial intelligence, cryptography, and privacy. And so it's been what I've been doing my whole career. Ended up creating an AI company focused on confidential AI. That company got acquired back in 2019 by Sonos and ended up being used in all the Sonos devices. So that was quite nice. And then started Zama in 2020 to work on fully homomorphic encryption for blockchain with my co-founder, Pascal Payet.
It's always interesting to talk to people who are in ML, before this kind of like last couple of years revolution. And like, was it kind of just you were kind of nerd sniped and just interested in this space? Or do you think you saw this massive potential that we're now seeing before everyone else did?
Well, I mean, very transparently, my previous company. So when I started getting to AI, it was my first year in college, 2003. I've been coding since I was 10 years old by the time I started college computer science. So I was kind of bored. And for fun, I was taking advanced master's classes. And one of those classes was on machine learning and AI.
Right.
And at that point, I discovered that you could actually teach machines to do things instead of having to program them to do those things. And that kind of paradigm shift for me was like, wow, okay, clearly this is where the future is going. Back in the days, machine learning was very limited to some use cases. We didn't have any of deep learning, any of those things. You could only do effectively trading and advertising and music recommendation. That was the extent of AI in those days. Fast forward to my other company, we were working on effectively language assistants, kind of like ChatGPT, Siri, those kind of stuff. But we didn't realize at the time, when we started in 2015, that you needed $1 billion to make this thing work, right? Very naively, we thought that raising a few tens of millions and just putting clever people in the room was going to be enough. And then when I sold it and I saw ChatGPT and I saw all of these things, I was like, I just didn't see that coming. I actually didn't think I needed $1 billion and like 1,000 GPUs to make it work, right? So in hindsight, a little bit early, but also didn't see the huge amount of compute that was going to be necessary.
You mentioned being interested in cryptography early on. What was your first encounter with crypto?
Cryptocurrencies. So first time I heard about it actually was 2009, 2010. My dad was a currency trader, right? Currency and commodities trader. Wow. And so in the trading circles, when Bitcoin came out, people were like, making fun of it, kind of like, oh, look at this funny internet money kind of thing. Kind of like we make fun of meme coins today. It was a meme coin for traders that were trading dollars and euros, right? And so my dad tells me, hey, look at this thing. What do you think? I'm like, okay, it looks interesting, but whatever, right? I was doing my PhD. I was, focused on something else at the
Right.
time. And then I got back into crypto in 2013 because a friend of mine who was like a early Bitcoin maxi was, basically just keeping talking about Bitcoin. I was like, okay, maybe I should take a second look. And so that's when I started getting into it. Bought some Bitcoin, bought some ETH, lost everything in 2017. When it started going up, I was like, I'm the best trader on the planet. Started leveraging to the tits, woke up one morning, done, liquidated. And I was like, shit. From that day, my strategy has been very simple. I only invest in early stage crypto projects like I would in a startup. And then I buy and hold. And that's it. Like I don't trade, I don't speculate, I don't leverage, none of that. I just buy and hold projects I believe are going to be important for the future of cryptocurrency, finance, and all of these things.
Right. Tell me about the early foundations of the idea and the problem behind Zama.
The first time I encountered homomorphic encryption, so FHE for short, for fully homomorphic encryption, was at my previous company where I was looking at confidential AI. And someone told me about homomorphic encryption. It's like, oh, you can compute on encrypted data. Started looking into it in 2015. It didn't really work at the time. There were multiple issues with FHE. You could barely do anything with it. It was very hard to use. It was extremely slow. But the idea kind of stuck. And, from the day I was like, this technology is going to change our relationship to data. Whatever data we're talking about, AI, blockchain, government data, everything changes when you can keep it encrypted and still use it as part of any kind of service you want to access. I met my co-founder now, Pascal Payet, back in those days, being curious about the topic. I'm looking up who are the top people in homomorphic encryption. And I see this French super famous cryptographer, Pascal Payet, his office was next to mine. So I was like, just going to text the guy and like, hey, do you want to meet up? I want to talk about FHE. And he's so nice. He's the nicest person in the world. He's like, yeah, sure. I'd love to talk to you about FHE. And that was the beginning. And so for 5 years, I've been waiting for the opportunity to work on that. And so a week after I sold my AI company, I started Zama to work on FHE.
And what, obviously, well, I guess let's just back up. FHE is the use of encryption, the use of encrypted data for kind of AI applications, or I guess any application generally, correct?
Yeah. So the idea of fully homomorphic encryption, FHE, is that you can compute on encrypted data without actually having to decrypt it. So let's take the example of AI because it's very simple. Today, if you're using ChatGPT, you're encrypting your data, sending it to OpenAI. OpenAI decrypts it, processes it, re-encrypts the result, and sends it back to you. So the data is encrypted in transit. So it's encrypted when you're sending and receiving the response, but it's not encrypted during the computation on the OpenAI side. So you see the data and OpenAI sees the data. With fully homomorphic encryption, you would encrypt the data with a key that only you hold, and you would send it encrypted to OpenAI, and they wouldn't be able to decrypt it. But the way it was encrypted still allows them to compute on it, to run their algorithms, to run their machine learning models on the encrypted data, producing an encrypted result that you can decrypt on your end. So imagine it a little bit like end-to-end encryption in a messaging app, but for any kind of online service like AI, like smart contracts on a blockchain, like cloud computing.
So essentially it allows whatever service to kind of perform the service without my data being exposed to them.
Exactly. So it's like they're computing blind. They have no idea what you send them. They have no idea what they're responding back, but the service is exactly the same from your point of view.
And when you were kind of in the early days of this, did you see kind of the applications of these? Were they clear to you, or did you just kind of understand that this technology would be important?
Well, so I mean, coming from AI and having been in crypto for a long time, I knew those were two important use cases, right? It wasn't clear to me where the market was going to be first, right? Because, at the end of the day, we're not a nonprofit, we're a company. And so we need to find a business.
Right.
I have great investors. Honestly, I'm so happy to have those investors because when I started a company, I told them straight out, I'm like, look, We need about 3 to 4 years of research to get FHE to a level that it's actually commercially viable. And during that time, we're going to figure out if we go for AI, blockchain, or something else.
Okay.
Right?
So sorry to interrupt, but what were the early obstacles around FHE? It was just slow and bulky, or what had to be accomplished?
That for sure. So there were 3 main issues. First, you could only do specific limited number of mathematical operation. You could add encrypted numbers, you could multiply encrypted numbers, but you couldn't really compare encrypted numbers. So imagine, for example, I want to know if you have enough money to send a wire. If I cannot check that, it's not very useful, right? So that was one limitation. We solved that by inventing a technique that allows us to compute any kind of mathematical operation exactly as if the data was not encrypted. That's solved. The second thing is that it was very hard to use. Unless you had a PhD in cryptography, it was very likely that you were going to mess up the security of your FHE application, and therefore it would be completely useless. We also fixed that. For example, our blockchain product enables you to write a Solidity smart contract without any knowledge of cryptography, and we take care of everything in the backend. The third problem was speed. So it was very slow. We're talking minutes to, do some mathematical operation. So yeah, good on paper, but not really useful in practice. Since we started a company, we've accelerated FHE by 100x.
Wow.
Right? And that 100x got us to a level where we can now, for example, taking token transfers, we can now do more encrypted token transfers than Ethereum can do non-encrypted token transfers.
Wow.
So sure, Ethereum is not the fastest blockchain, but we're now faster than Ethereum. First milestone, done. That's what 100x gets you. Now the question is, how do you get to Solana levels of speeds? How do you enable Swift and Visa on chain, like 100,000 transactions per second? For that, you're going to need, of course, better mathematics and everything. But really at this point, it's purely a question of better hardware. More compute, more speed, more throughput, more use cases. So we reached this inflection point, kind of like AI did with LLMs and transformers, where it just became a question of more compute. We're at that stage for FHE. Put GPUs, put FPGAs, put ASICs, and you'll get to 100,000 TPS. It's not a question of mathematics, not a question of research. It's purely a question of money and hardware. That's it.
Right. So talk to me about the markets that you guys thought about approaching and how you came to address the markets that you're addressing today.
We looked at so many things. We've looked extensively at AI, extensively at advertising, healthcare, defense, like all of those big things that people tell us privacy is important, right? But one thing that always bothered me is I looked at some of my competitors, great companies, great founders, good technology, good product, good business people, and they don't have product market fit. And they're all going after those use cases.
Right.
And so I look at that, I'm like, I don't think I can do better than these guys, right? So if they don't find it, maybe the market isn't there. So I put aside the whole cloud Web 2 side of FHE and decided to focus on blockchain. Why? Because if you think about it, a blockchain today, all of the data on chain is public. It's public because people need to verify the state to make sure that the blockchain did what it's supposed to do.
Right.
So you had this kind of dilemma that either you had public verifiability or you had confidentiality, but not both. And I look at this, I look at all the financial institutions and people wanting to use blockchain for paying salaries, for all that kind of stuff. I'm like, well, something's missing here in the middle, and we probably can fix that with FHE. So we built effectively the first confidential smart contracts protocol. And immediately, we had incredible feedback, incredible, deal flow, and just people starting to build on it before it was ready. And that for me is the best indicator of product market fit. When people are willing to build a company on a technology that is not even in production yet,
right.
You're solving a really important problem, right? So we're like, okay, that's the market. That's the market for FHE. Let's go all into it. And that's why we ended up, building the Zama protocol and all the things around it.
It's interesting. The technology that you guys have created is kind of fundamentally like, it's not it's a level up, right, on existing technology, right? So, Ethereum works in this, open state, right? Non-encrypted, non-confidential. And then you guys kind of upgrade the technology. Talk to me why you think blockchain has been so successful, and then why you think Zama is so important to kind of add additional functionality to it.
To be honest, I don't consider blockchain to have been yet fulfilling its promises. Bitcoin did, right? But because people don't use Bitcoin for confidential stuff like paying salaries or things like that, they buy Bitcoin and hold it, right? So Bitcoin as digital gold, sort of nuclear war hedging makes total sense. And that was a killer use case. When people say that 10% of the population holds crypto, they mostly hold Bitcoin, right? They don't hold ETH or tokens on ETH or things like that, right? Not yet, at least. And all the promises of like, hey, we're going to run, governance on chain. We're going to run finance on chain. We're going to run company registries on chain, cap tables on chain, secondary sales on chain. I'm going to have my house on a blockchain. There's no way that's going to happen unless you figure out confidentiality. So confidentiality was always this sort of thing that people know was important for adoption, but because it wasn't available, people tried to ignore it and say that nobody cares about privacy. That's false, right? And we see it now. Like payments is a great example. Take out your phone.
It's in the other room. But.
All right, okay. So if you took out your phone now and opened your bank account, Revolut or whatever you're using, right? And you gave it to me, how would that feel?
Terrible.
Exactly.
In fact, there are like current payment apps that broadcast your social, your transactions, and
it's a terrible idea.
It's horrible.
It's a horrible idea. You wouldn't give someone your bank account, so why are you giving them your wallet on chain, right? So I believe, and I strongly really believe that. I think that we're just starting with blockchain, and I think confidentiality is the last missing piece of the puzzle. We figured out scalability. Solana, L2s, doesn't matter the way you do it, blockchain can scale. Confidentiality is the last piece for mass adoption.
Right. So it's not like framing it as an upgrade is not even true. It's actually, it's part of the base on which everything else will be built.
Yeah, it's you need three things for any major, market to adopt the technology. You need security. Ethereum gave you that. Ethereum made it secure to hold assets on a decentralized ledger.
Right.
Done. Security, that's blockchain. Public verifiability gives you security. The second thing was scale. You need to be able to do a lot with that secure infrastructure. That was a big bottleneck initially. So we had, the whole wave of super fast L1s, L2s, shardings, all those different flavors. I think we can say today that scaling is pretty much solved in blockchain, right? And the third thing was confidentiality. And you really want those three things. You want security, you want confidentiality, and you want scalability if you want to be able to use a blockchain for finance, for government services, for all of those things we've been promised were supposed to be revolutionized by blockchain. So it's not just that confidentiality is the only important thing, is that it was the missing thing of those three important things that other people already fixed.
Right. What are the most interesting kind of specific use cases where you see kind of this 0 to 1 moment in crypto today?
In crypto or with confidentiality specifically?
With confidentiality specifically.
I think for me, confidential payments, that's such an obvious one, right? Everybody wants to use stablecoins for paying everything, but nobody wants to do it in the clear. Right, so I think that's going to be probably the main driver of adoption for Zama and for FHE, and it's also very easy to scale because the good thing about payments is payments are typically independent of each other. It's very rare that one person pays out 1 million person from the same account. Right. Usually it's like I pay you, and then maybe these people pay each other, and that company pays that person. So it's kind of like distributed. Everything that is distributed and independent can be scaled in parallel, right? So if you tell me we want to support 1,000 confidential token transfers per second, I'll just put more servers behind it because they're independent of each other.
Right.
What's harder is if you want to start doing sequential things. For example, if everybody's trading from the same, DEX pool, then the liquidity is updated every time there's a trade. So
Right.
those have to be sequential.
And it's contingent on other actors constantly.
Exactly. So that's harder to scale because you cannot put just more servers behind it. You have to make the speed of a single transaction much faster. And that's where the FHE hardware comes in, right? So with the current state of FHE, with existing hardware like GPUs, we can probably, we're not doing it yet, but we can probably by next year support 100% of on-chain stablecoin payments.
Wow.
Okay? Because we can parallelize. We cannot yet support 100% of trading and swaps because of the sequential nature. That's going to require hardware, FPGA ASICs, which are going to make FHE another 100x faster. And when that happens, then effectively there's nothing you cannot do encrypted on chain. And so the vision we have here is, you know, the same way that we went from having no encryption on the internet to having things encrypted when we're sending it, you know, with HTTPS, the small lock, you know, in your browser. We went from, I think, 13% usage of HTTPS for internet traffic in 2010 to about 95% today. Okay. I think the same thing is going to happen for blockchain. We're going to go from no encryption in blockchain to 90+% of blockchain transactions being encrypted with FHE in 10 years. So we really see like this technology as HTTPS for blockchain effectively, right?
There's kind of actually a parallel with crypto itself, right? Where kind of crypto came in and promised to be a solution for a lot of finance. And then now we're seeing the adoption, right? Especially lately, we've seen institutions come on.
And you know what they ask for?
Privacy.
Yeah. Well, that's for confidentiality, which is a bit different, right? Privacy relates to personal data. Confidentiality relates to any data you want to keep private.
Right.
Right. So for a bank, you know, their trading positions are not technically personal data, but they're confidential information they don't want to divulge to everyone. And, you know, I mean, if you think about finance, the whole point of finance is to know something other people don't, right? That's your alpha. Like, that's how you win at being a trader, right? You cannot have that if everything you do is public, right? And I don't even think it's legal. I'm pretty sure they cannot just like broadcast publicly everything they do, right?
Right.
So no, I don't think there is going to be institutional mass adoption of blockchain for finance unless we actually have confidentiality, and that's exactly what we enable.
And then talk to me about the form factor of your product, right? Like, where does it sit in the stack?
We kind of did it the other way around. We started by licensing our technology to other blockchain protocols so that they would integrate confidentiality into their ecosystem. So today, 9 out of 10 blockchain project that says they use FHE is actually using Zama's technology. They just don't say so, right? And we're fine with that. Like, you know, as a technology provider, anybody can come and license our technology is completely okay.
Right.
But we realized that a lot of people didn't want to build a new chain. They wanted to build a confidential application on top of existing chains like Ethereum or Solana or Base or Shiba or whatever, right? And we didn't really have a good solution for that because Ethereum is not going to integrate FHE natively. It's just too much compute power for FHE, for Ethereum nodes. So we built this new protocol called the Zama protocol, where we can now actually have FHE and confidentiality on top of any public blockchain, even if they don't integrate us natively. And you can think a little bit like, you know how like bridges add like interoperability between chain? We're kind of the same stuff, but for confidentiality. So we're bringing confidentiality to existing blockchain. We're not a new L1 or L2. We're something that sits on top of those other chains. And the way it works is actually very nice. Like, my team is so great, man. I'm very happy about the people we've been having at Zama. Instead of the actual blockchain doing the computation, which would be too expensive, what we do is we do a fake FHE execution on Ethereum, for example, and that fake FHE operation in the smart contract will emit an event saying, hey, can someone please actually do that computation for me and store the result at that particular place? And then the Zama protocol has operators that monitor the activity on Ethereum, on all of those blockchains, and are basically picking up on those events and doing the actual heavy lifting and store the result in a DA so that the user can access it whenever they need to later. So we're effectively using external co-processors to augment public blockchains with FHE capabilities without any impact on the underlying blockchain itself. And that is like, if you want the kind of big breakthrough is, we don't need Ethereum to integrate us. We can just deploy on top of it.
Right. Are there any, obviously, like bridging is an example you used here. Bridges have a famous, they're obviously much better now, but they have kind of a famous, some famous issues with security. Does Zama face some of those same issues in security, and how have you guys solved those challenges?
I think bridges today are pretty secure. That was true in the early bridges,
Right.
I agree, because it's basically just someone with a key, right? I think now they're a little bit better. We're very close to some of those folks, and I can tell you they're incredible, companies.
Right.
So for Zama, we have a set of 16 operators, but those operators are all known publicly, so people know who they are, and all of them have a lot of reputation and stake, at stake, I guess. So they're typically large validators that have multiple billions at stake in other protocols, right? They're large foundations that have big tokens. There are financial institutions, exchanges, wallet providers. If any one of those cheats, anybody can see it, and anybody can request to slash them, which I believe would not just make them lose their stake in the Zama protocol, it would also impact their reputation outside of the Zama protocol and effectively make them lose business and everything else they're doing.
Right.
So the economic security of having high quality, extremely successful operators that are publicly known, I believe the economic security of that is the sum of everything that they do outside of Zama as well. So sure, like if you think that they're okay, wasting billions of dollars of revenue and stake, then everything is possible. But
Right.
in practice, when you look at blockchain and you look at things like optimistic rollups, people don't cheat if they can get caught, right? They cheat if they cannot get caught.
Right. So there's kind of multiple layers of security built in.
Yeah, and to be clear, this is just the node operators, right? But there is also the security of FHE itself.
Right.
FHE as the technology is post-quantum, meaning that even a quantum computer cannot break the encryption. So the only way to break the security of the Zama protocol would be to corrupt a majority of the Zama operators, right? And do it in a way that you would not get caught, even though everything is publicly verifiable. I don't see how that can happen.
Right. And I guess it's important to note, too, that we still have the economic security of the underlying protocol.
Of course. I mean, by the way, everything is economic security, right? At the end of the day, even Bitcoin is economic security because it's the cost of, running those miner rigs, right? Like it always comes down to someone paying money for something, right? And that person pays money because they're making money on the other side. So it's all about economic security in the end.
There's also, sorry, I lost my train of thought. I'll start back over. There's also an interesting, we haven't chatted about it. We've mostly talked about like the crypto side of things, but there's also interesting applications around HFE and, FHE in the AI space. Can you touch on that a little bit?
Yeah, so I come from AI, right? And I've been trying to figure out confidential AI for a decade now. So I'm gonna get there eventually. I'm a believer. The issue we have today is we have a great AI product, by the way. It's called Concrete ML. It allows you to effectively use a scikit-learn type of front end to have confidential machine learning models.
Okay.
So it's very easy to use as a data scientist. You just write Python code, and we take care of everything. Kind of like, for blockchain, you write Solidity code, we take care of everything. For AI, you write Python code, and we take care of the rest. In practice, we haven't found product market fit. And the main reason for this is twofold. First, many companies are happy trusting a service provider with their data because if the service provider fucks up, they can get sued, right? So the legal system...
Right. Serves as kind of the...
Exactly. Serves as like keeping everybody sort of honest and trying to be secure, right? It's going to change eventually, but for now, at least, that's what we saw. The second problem is for large language models, which is the bulk of the AI market right now, LLMs, right? ChatGPT, Anthropic, these things. They're so compute constrained that even at 20% overheads would basically destroy their margins, right? So the budget that these companies have for confidentiality is very small. And there is no cryptography technique, FHE, ZK, MPC, you name it. There is no cryptography technique that is secure that fits within that budget. So either we need to figure out how to have a lot more compute for AI, in which case we can fit in confidentiality,
right?
Or we need to drive the cost of AI down or make the model smaller. But something has to change because in the current state, it's economically infeasible to actually bring privacy to AI.
So it's almost like a good example would be what you were talking about with the encrypted internet, right? It was the technology was not there yet.
Yeah.
It was just too early almost.
It was too early. I mean, it's going to change. I still believe that, and I'm going to continue working on confidential AI. Just realistically for Zama, the company, blockchain is our major use case right now, right? And that's okay. A part of building a startup is finding a market and building a product and then, solving a big problem for a lot of people. And I would argue that FHE for blockchain already solves a major problem. AI is going to come later. It's going to come, but as you said, it's going to come later.
Are there any other kind of frontier applications of FHE that you're curious about?
Yeah, so it's still related to blockchain, actually. We talk a lot about payments, finance on chain. This is the big meta for the past, couple of years, and actually 5-6 years, I would say. Right. That's what we're currently solving. Bring finance on chain, make payments confidential, 24/7, stablecoins, all these things. I think that the future of blockchain beyond finance is going to be to run all of these social and government infrastructure on chain. Company registries, land registries, identity registries. Your passport will be on a blockchain. Your car will be on a blockchain. Your house is going to be on a blockchain. Everything you buy is going to be on a blockchain, right? And if you think about the scale of that, it's absolutely gigantic because there are 8 billion people on Earth today, and there are 8 billion people that have a government. Right. So you talk about bringing the next billion to blockchain. Well, let's bring the next 8 billion to blockchain. And the way to do that is to tokenize and blockchainize government services, right? And government services are not that complicated to run on a blockchain because they don't require a lot of compute. We're not talking about an AI model. We're talking about paying your taxes, once a year. We're talking about buying a house once every 20 years, right? You know what I mean? Like they're punctual, small actions, but with very big consequences. That's exactly what you want to use a blockchain for, right? But you need confidentiality, right? You're not going to have your passport on a blockchain publicly. You're not going to have your address on a blockchain publicly. You're not going to have, any of those things out in public. And so that's why I believe that FHE and Zama not just enables confidential finance, but also enables, what we call the on-chain state OS, a whole operating system for countries to run on-chain with confidentiality.
Yeah, it's moving from this kind of limited pool of finance, limited but obviously massive pool of finance, to anything kind of consequential in your life.
Yeah, exactly. And that for me is like the ultimate vision for blockchain. It's not just about programmable money. It's about programmable identity, programmable governments, programmable cities, whatever you want to actually make composable, programmable, tokenizable, and super, super secure, you can put in a blockchain. So I think, frankly, this state OS sort of long-term vision is one of the things that drives me the most in blockchain today. I love finance. I love all of those things. My dad was in finance, so I come from that, right? But if I think about what is going to be the most revolutionary, game-changing, world-changing application of blockchain, I think it's going to be the day that you can have on-chain governments and on-chain countries.
Very cool. There's one other important thing to note about Zama, and it's that not only are you kind of running cryptographic technology, but you're also running the protocol on a cryptographic layer, on a decentralized layer. Why was that so important to you guys when building this out?
We've been licensing our technology to other blockchain protocols for a while, but we wanted a solution that would enable anyone to build a confidential app on any public blockchain, even if they were not customers of Zama, right? And having the Zama protocol is a way to basically solve that by enabling FHE on non-FHE powered blockchains like Ethereum or Solana.
Right.
So that was the reason for building the Zama protocol. So we have both, and we still have the licensing business. Think of it a little bit like a cloud SaaS type of company. You have your hosted version. So in our case, we don't host it. It's the operators that host it, but that's the Zama protocol.
Right.
You just want to build an app. You don't want to run infrastructure. You don't want to bother with any of that. You use the Zama protocol. But you can also use the same technology on-prem as a self-managed thing that you own, and you decide how that runs, and you decide who runs it, and whatever you want to do, right? So I kind of white labeled Zama protocol for your own needs. That's our licensing business. This existed in Web 2 forever, right? SaaS companies have on-prem enterprise versions. It's exactly the same thing here. And by the way, Arbitrum does that. They have, the Arbitrum chain, and then they have, the Arbitrum stack that you can license.
Right.
Optimism does the same. It's actually something that's very common, but for some reason, we haven't called it for what it is, which is, cloud versus on-prem for the same thing.
Yeah, it's very standard in like the traditional software space.
Make it standard, man. Look, we're just building businesses. Let's stop reinventing everything. Let's just use tried and true business models and architectures.
Right. What's your greatest ambition for Zama?
Our first goal now is getting to Mainnet. So we just launched our testnet. By the way, thank you to everyone who's been trying it. People have been a little bit too excited. We averaged 5 to 10 transactions per block on Sepolia testnet. We spiked the Sepolia gas price. Sepolia, by the way, is the Ethereum testnet, right?
Of course, yeah.
We spiked it to 150 Gwei. People just got really too excited, and they broke our testnet. So we're like, wow, we've been stress testing our testnet internally for like weeks, and we couldn't break it. And we put it out, and within an hour, people break it. And it's great, because it made me think, actually, we all like to hate on people farming and botting and spamming your network. But when you're building critical infrastructure, you want that kind of stress test. So the community is actually doing Zama a massive favor by breaking and trying to throw, I think we had 1 million transactions since yesterday, since we launched
insane.
Right? That's a good thing, right? At least we have the data, and we know where the bottlenecks are, we know where things are failing, and now we can fix it, right? And if we can fix it, we can make it more robust, and people can trust it more, and people can use it more. So very happy about the testnet. We're number one trending accounts by followers on Farcaster. We're trending on Twitter. We're trending on Dune. And we haven't even done paid marketing. We just put out this thing and be like, that's
Try
what we're
it.
doing.
Yeah, use it.
And that tells you that there is something, we're hitting a nerve. People know that FHE is an absolutely key technology for blockchain, right? So testnet, going great. If you consider that people have been breaking it and we've been fixing it, nonstop for the last 24 hours. Next goal is Mainnet. So we're going to do a first Mainnet just for confidential applications on Ethereum. That's going to be sometime probably in October. The goal will be to have only a few apps initially that we authorize on the Mainnet, just to kind of get the ball rolling, make sure that things are stable.
Right.
And then sometime by the end of the year, we're going to have a TGE and then open it up to anybody and launch it on multiple chains and everything. So I cannot really tell you more about that yet, but all I can tell you is what we've got planned for the TGE is unheard of for a company of our size, of our maturity, who raised that much money yet.
Mm-hmm. Yeah, and really it's exciting because it's almost a new form factor of like how people build in crypto, right? Where I'm building on Ethereum and then I'm building on a secondary technology. And I can think of a few examples that are similar, but nothing as extensive and robust as Zama. And I think that's very interesting.
I think I can safely say today that we are the most advanced cryptographic protocol ever to go in production. Mm-hmm. The amount of things that we had to invent to make this work is insane. We talk a lot about FHE, but FHE is one piece of the puzzle. We had to invent completely new techniques for ZK, for MPC. I mean, we're touching every single cutting edge cryptographic construction that people came up with and we came up with. And you need that because the problem is hard. There are many people that are like, oh, we can do better than Zama, we can do better than Zama. And when someone say that, I look at it, obviously, like, if you do better than us, we're just going to either buy your company or license your technology because we just want whatever is best, right? And when you look at it, there's always something that's broken. Maybe they had a shortcut under security assumption and it actually isn't as secure as they say it is. Or maybe they're benchmarking on some, very specific use case and it doesn't really work for everything else, right? Or maybe it's not publicly verifiable and you just have to blindly trust that it does what it's supposed to do. Or maybe it's not composable. You can use it, but you cannot have like DeFi on top of it.
Right.
There's always something that was missing in the puzzle. We are the first protocol that genuinely has an answer to all of the things that people want from a blockchain. Mm-hmm. Are we going to be right? Future will tell. But it looks at least like it's going to work and that people care.
You mentioned that the future will tell. How do you benchmark success 1, 5, 10 years down the line? What does Zama look like? And
for me, it's very simple. Percentage of blockchain transactions using Zama for confidentiality. On the top 20 chains right now, today, okay, so July 2025, you have about 3,000 transactions per second, 3,000 TPS, right? If we can already get to 1% of that, it would generate about $100 million per year of protocol fees for the Zama protocol. Right. Just 1%. That's it. Not asking for more, right? But 1% is not fun, all right? So really what we want is 10%, because 10% would get us to $1 billion per year in protocol fees. Right? Now we're talking serious business, right? But if you are at 10%, why stop there? So as I explained earlier, I think that FHE is going to follow the same trajectory that HTTPS did for the internet. Mm-hmm. We're going to go from 1 to 5 to 10% over the next 3-4 years, maybe. But 10 years from now, I'm convinced over 90% of blockchain transactions are going to be encrypted with our technology. I'm convinced about that because everybody wants it. And once the cost of doing it is cheap enough, there's no reason not to.
And if in the meantime we're scaling from 3,000 to 30,000 to 300,000 to 3 million transactions per second, now it's become something truly revolutionary.
That's where you need the hardware, right? So there are multiple companies, including us, working on building a dedicated chip to accelerate FHE. Our estimate is a single one of those chips could do about 10,000 confidential token transfers per second, right? You can put 8 of them in one server. So a single box in a data center could do 80,000 TPS per chain. Right? Not so bad, right? And you can put 20 of those boxes, of course, right? So I think scale is done, man. Like, I've got a clear plan on how to make FHE more scalable than any blockchain today. The bottleneck will not be FHE. The bottleneck will end up being blockchain. I'm convinced about that. FHE is not going to be the thing that prevents people from using a blockchain in the future. So,
and that obstacle would be just the speed of the blockchains themselves?
Yeah, because blockchain, you have consensus. So, FHE is a compute problem. Throw more compute, it goes faster. It's that simple. Blockchain is a consensus problem. You need to coordinate multiple people over a network that has latency. It's a speed of light in communications problem. There is a physical limit to how fast a blockchain can go if you have nodes distributed across the planet. And we don't know what the limit is. Maybe the limit is 1 million TPS, right? But it's latency and network bound. It's not compute bound like FHE.
Right.
So we're just going to keep throwing more compute at FHE until we get to this point where we're crossing the level where the compute is less of a bottleneck than the consensus of the blockchain.
Whether from a technology perspective or from a personal perspective or from building a company, what has been the greatest lesson you've learned from building out Zama?
I actually learned a lot in my previous company too. Building an AI company, that was not easy. Very happy about it. We sold it. Everybody was happy. But when I started Zama, there are a lot of things that I did different, right? And one of those things was don't reinvent the wheel. Find one problem and be the best at solving that problem and just reuse whatever other things people built for everything else, right? And that just made us go so much faster because we're core razor sharp focused on one problem, which is making confidentiality on chain more scalable, faster, and cheaper. That's it. That's our only thing. We're not reinventing blockchains. We're using existing stuff. We're not reinventing finance. We're just doing whatever they want us to do. We're not reinventing hardware, right? We're using GPUs now. I mean, we're going to be reinventing some hardware in the future, I guess. But you get the point, right? We have only one problem to solve, which is making FHE faster, cheaper, and more scalable. That's it.
And if you combine that with a market that's ready for it and sees the value, and that can kind of create this Cambrian explosion.
Exactly. And I think now you know why we've been fortunate to have such incredible people join the team, because they see that vision. Also why we have been fortunate to have incredible investors, right? Multicoin, Protocol Labs, Blockchain, Pantera. These are the most successful crypto funds, right? And they saw the opportunity in Zama and FHE as just being a game changer for blockchain, right? And now finally that the community has a chance to try using our stuff, and soon to actually also, use actual apps in Mainnet, we're starting to see that people care. And to be clear, people care because they see the problem, but actually believe that in the future, people are not going to care about privacy and confidentiality anymore, not because it's not important or because they gave up, but because it's going to be such a default part of using a blockchain that it's just not going to be a problem to talk about anymore, right? So if we do our job right, people don't know Zama exists, right? Because we're just like this confidentiality layer that protects people's data on chain in the background.
Right. The ultimate goal is to be so comprehensive that it's just assumed that it's you become a standard.
You don't think about HTTPS, right? But it's there. And we want to do the same thing for blockchain.
Phenomenal. Rand, I think that's about it for time for us. It's been a pleasure chatting with you. You're an excellent storyteller.
Thank you for having me.
And I've loved to hear your vision. Thanks so much for being here.
Thanks.